This session discusses insertion sort. So given an n number of elements, this will sort the elements in either ascending or descending order. So we will see an example where the elements are sorted in ascending order. So we will start with an example. So we have elements 6, 5, 4, 3. 4 elements which are in descending order. So after the insertion sort, this will be sorted in ascending order from the smallest to the largest. So the idea of insertion sort is we will start from the first element, the leftmost element, and if you have only one element, it is already sorted. So we move to the next element, 5, and we compare it with the left portion. So in that case, you can see that the left side is already sorted. So what it does is, if this element is less than the leftmost left element, then it will be swapped. So this will become 5, 6, 4, 3. So next we move the pointer one element to the right. So we consider 4, and now our assumption is that the leftmost left elements, left side is already sorted. So again we do this. We compare 4 with the 6. Since 6 is greater, we will swap this. So it will become 4, 6, 3. Then 5, 4, 6, 3. Then we compare this 4 with the next element. Again you can see that the left element is higher, then we will be swapping. So this will become 4, 5, 6, 3. So we will be doing this checking and swapping till the end, or the element is lesser. Next we move one position to the right. Again we will be checking. So in this case we assume that the leftmost portion is already swapped. So again we will be checking. 3 and 6 are checked and swapped. So this will become 3, 6, 4, 5. Again 3 and 5 are checked and swapped. So this will become 4, 3, 5, 6. Again we will be checking 3 and 4, and since 4 is higher, larger, we will be swapping. So this will become 3, 4, 5, 6. So we have reached the end. So we stop. So if you see that the process, this needs 2 loops, one for moving to each position of the elements. So we start from 6, then we move to 5, then we move to 4, then we move to 3. At each position we need a loop to check the left elements, which is used for swapping. So we need 4 loops. So in this process, what we will be doing is, we will be starting from the second element, since we assume that if you have only one element, it is already sorted. So we will be writing the algorithm as I equal to 1. So to select this, then what we need to do is, we need to move from this to the last element. So we will be writing a while I less than, our array name is A, length of A, while I less than length of A. Then what we need to do is, we need to use another variable j equal to I. Then we need to move to the left and compare. So this should be done while j greater than 0 and a of j minus 1, a of j minus 1 greater than a of j, a of j minus 1 greater than a of j. If this is true, then a of j minus 1 is greater. Then we need to swap a of j and a of j minus 1. So while loop ends here, and so after moving to the left and the swapping procedure is done, you need to increment the value of I to select the next element. So I equal to I plus 1. So you need to end this while. So this is the algorithm for insertion sort. So next we will see an example, another example, when the elements are already sorted. So in ascending order, we will be seeing the same example. 3, 4, 5, 6. So we will start from the first. We will be selecting I equal to 1 while I less than length. So this, what this loop does is, we will be traversing all the elements from the first element j equal to I, while j greater than 0, j is 1. The indices are 0, 1, 2, 3. So j equal to 1 while j greater than 0 and a of j minus 1 greater than a of j, which means that we will be checking with the left elements till this part, and if this element a of j minus 1 the element greater than a of j. If a of j minus 1 element less than, which means that there is no need to move to the left since the leftmost elements are already sorted. So here you can see that a of j minus 1 greater than a of j won't hold. A of j minus 1 is less than, so which means that left element is already sorted. So this, it won't enter into this loop. Then you need to move to the next portion. We'll be selecting this 5 and we'll be checking with 5 and 4. So 4 is less than, which means that leftmost elements are already sorted. So we move again one position to the right. So again we will be checking using this while loop. Again you can see that the leftmost elements are already sorted since 5 is less than 6. We have reached the end of the elements. So this will stop. And you can see that elements is already sorted. So what this shows is this set of elements, in the case of this set of elements, after moving to each element, after selecting each element, this while loop is ended and the swapping procedure is done for each element. Or I can say that this is a worst case. This is a worst case. And here there won't be any swapping when the elements are already sorted. So I can say that this is a best case. So worst case of insertion sort is when elements are sorted in descending order and you need to sort in ascending order. And the best case of insertion sort is when elements are already sorted in ascending order. So coming to the complexity, we need to, in an algorithm like this, the idea is to count the number of times the loops are executed. So you can see that this loop will be executed sometimes n minus 1 times if there are n elements, since we are starting from 1. So this is of the order of n minus 1 and this will be executed In the waste case, only in the waste case this swapping procedure is done, which is also executed about n minus 2 times. This swapping n minus 2 times in all. For each part, for each element, this will be executed in the waste case. So, if you take the waste case, this will be a order of n minus 1 times n minus 2 times. So, if you expand this, the highest degree term is n square. So, I can say that the complexity is of the order of n square in the case of waste case. In the case of waste case. But in the case of best case, this swapping is not executed at all. There will be this while loop only executed. So, in the case it will be executed only n minus 1 times. So, you can see that this will be executed of order of n minus 1, which is equal to order of n. So, in the case of best case, insertion sort runs in O of n time. The best case is when the elements are already sorted.